Hello all, I'm Siddharth Kaul and I welcome you to Edupedia world. In this video, we are going to take a detailed look into logical classes. In this video, I'm going to primarily focus on the aspects of logical class by providing use cases. These use cases will contain how logical class is used to identify and solve certain problems. The first major use case I'm going to go into is finding the array elements that meet a condition. Consider an array, random array. This is a 5 cross 5 array in the first box. So it's created using a function random. Where I have randomized each element from 0 to 15 and I have declared the size as 5 cross 5. So here I will apply only one condition. So the condition that I have applied is a less than 9. See, the A here is the matrix and 9 is a scalar. So using the relation operator between matrix and a scalar produces a result similar to shown here. The result is a matrix of 1 and 0. Here in this matrix, 1 occupy the places where the condition has been met and 0 occupy the places where condition has not been met. Basically, this matrix B contains information about which elements in A are less than 9. But it does not tell you what the value is. So what we can do in this case is use matrix B as an index for matrix A. So on the left, I have used matrix B as an index to bring out all the values from A that are less than A using matrix B as an index. The result is a column vector of elements in A that are less than 9. Since B is a logical matrix, this operation is called logical indexing. In this case, the logical array behind used is an index is the same size as the other array. But this is not a hard and fast requirement. So this is to handle like one kind of problem. In some other problems, information such as location is of greater importance than the value itself. So what to do in that case? So for the same purpose, we use the find function to know the location of all the elements in matrix A that are less than 9. So on the right, I have used the find function with condition A less than 9. That will result in a column vector containing the location in matrix A at which the elements has value that is less than 9. We can use logical and, logical or and logical not operators to apply any number of condition to an array. The number of condition is not limited to just 1 or 2. Let's take matrix A as shown in the bottom. I have applied 3 multiple conditions that are shown in 3 boxes numbered 1, 2 and 3. In the first box, I have given condition that is A less than 9 and A greater than 2. The result is a column vector with all elements from A matching the criteria. In the second box, I have given condition that A less than 9 and not mod of A2. So the use of logical not operator converts the matrix mod A, 2 into a logical matrix with the value of logical 1 located where an element is evenly divisible by 2. So basically this condition is number less than 9 and number should be even. So resulting is a column vector as shown in 2. So as you can see, the number of elements have reduced. Finally, in the third, we have third condition where number less than 9 and even and the number is not 2, that leaves only 8. So this is how we can use logical classes to meet multiple conditions. The same trick that we use to find the element in a matrix that meets certain condition can also be used to replace the values of said elements to our desired value. Say for example, in the first box, like here in the top matrix, I have applied a condition that number should be greater than 10. And using this condition, I am going to replace all the values of A that are greater than 10 with 10. This way, I am ensuring that the matrix has the maximum value of 10. Now what I'm going to do is I'm going to replace all the values that are not 10 with not a number, making the matrix A have values only 10 or not a number. So that I have done by putting a condition A not equal to 10 and assigning it in NaN. So wherever in matrix A where the value is not 10, it will get replaced by an NaN. So this matrix here has only value 10 and NaN. Now I'm going to replace all the NaN values in A with 0. So what I'm going to do is I'm going to use a NOT operator to generate a matrix that has values of 1 that that makes the values of 1 in place of NaN and 0 at place of 10. So using the NOT operator actually converts the numeric array into a logical array so that the output result has only value of 1 and 0. To determine whether an array is logical 1 or not, we can test the entire array or each element individually. This is useful when you want to confirm the output data type of a function. So one of the ways we can know whether the matrix is logical or not is using the whose function as shown here. Here we are applying the condition that value should be greater than 0.5, then the result will be a matrix A with nothing but 1 and 0. By checking the A with function whose, we get the size that is 3 cross 6, the bytes that is 18, and the class as logical, hence confirming that our matrix A is a logical matrix. Another way to know whether the array is logical class or not is to test the entire array. This is done by using one of the two functions. So first function is the isLogical function. So by passing the matrix A to the isLogical function, we get return output as 1 or 0 depending on whether the matrix provided is a logical matrix or not. Another function is function class that will return a string that will be logical if the input matrix becomes to the logical class. So basically class function will return as a string logical if the matrix passed is a logical matrix. So here I have summarized the function that we can use to determine logical arrays. So we have a whose function, we have isLogical function, we have isA function, we have a class function, we have a self function, and we have a array function. So the most common ones used are whose, isLogical, isA, and class. So you can clearly read it here or you can refer the help documentation for the same. As seen before, most of the times we get an array of numeric and logical values, but sometimes it is nice to have only a single scalar or logical value. In such cases, we use any or all function to reduce the array to a single scalar logical for further computations. The any and all functions are natural extension of logical or and. However, rather than comparing just two elements, the any and all functions compare all of the elements in a particular dimension of an array. It is equivalent to having all the elements being connected by a single long chain by or and AND operators. And the any or all functions evaluate the resulting long logical expressions. Therefore, unlike the core logical operators, these any and all operators reduce the size of the array to only one single value of either 0 or 1. Let's see the matrix A as shown here. It's a random matrix with the value that can fluctuate from 1 to 25 and its size is 5 cross 5. Now I'm going to apply a condition to determine the elements that are even. The resulting matrix will be of same dimension as that of matrix A, but with the values of only 0 and 1. 1 will populate the places where the element is even. So we can use any and all in one of the ways as demonstrated here. So I have two ways that I can think of. First one is we can check whether if any of the element of A is even. As in this case it is true, so we will get a single logical value of 1. The second one is where I have checked whether all the elements of A are odd or not. So as this is not the case, as most of the elements are even and some elements are odd and not all the elements are odd, and in this case we will get a return value of 0. I'm going to close this video by showing a reference table that shows the results of applying the binary logical operation to a series of logical 1 and logical 0. So we have an input A, input B, then we have an ANDing between A and B, ORing between A and B, XORing between A and B, and NOTing of A. So when input A and input B is 0, AND is obviously 0, OR is obviously 0, and XOR is obviously 0. But the NOT operator to A input A is 1. Similarly, when input A is 0, input B is 1, we get AND as 0, OR as 1, and XOR as 1. Similarly, when input A is 1, input B is 0, then we get AND 0, OR 1, XOR 1. And when we have both input as 1, we get AND as 1, OR as 1, and XOR as 0. So this is the very common thing that we already know. I'm just putting here just for the sake of showing the information. This concludes our video on logical class. In the next video, we are going to take a look into characters and strings. So until then, please subscribe and thanks for watching.